So now the next step is to remember that this limit, when you evaluate it, it becomes 0. So we have sine x multiplied by 0. And then this limit, when we evaluate it, it becomes 1. So we have plus cosine x multiplied by 1. So if we have 0 plus cosine x, that just becomes cosine x. So our derivative for sine x, or we'll just write d over dx sine x, is equal to cosine x. And so if the derivative of sine x is cosine x, does that mean that the derivative of cosine x will be sine x? Well, we can always prove that with the limit definition. So before we actually get to proving it, do you think it will be sine x? Pause and make your prediction. Okay, now that you made your prediction, let's start with the limit definition again. So we have the limit of f of x plus h minus f of x all over h as h approaches 0. And in this time, f of x is cosine x. So now what we need to do is we write this limit again. So it's cosine of x plus h minus cosine of x all over h. And then once we expand cosine of x plus h, we get cosine x cosine h minus sine x sine h minus cosine x all over h. And like we did with the sine, what we should be doing is grouping all terms with cosine x in one side and then all terms without cosine x on the other. So we have cosine x cosine h minus cosine x minus sine x sine h all over h. And so now this setup seems somewhat similar to what we did for sine. And so now we can take out a common factor of cosine x and split this fraction. So we get cosine x multiplied by the limit of cosine h minus 1 over h as h approaches 0 minus sine x multiplied by the limit of sine h over h as h approaches 0. And so now this limit, when we evaluate it, it becomes 0. So we have cosine x multiplied by 0. And this limit, when we evaluate it, it becomes 1. So we have minus sine x times 1. And so when we simplify all of this, we get negative sine x. So the derivative of cosine x, or d over dx cosine x, is equal to negative sine x. And then if we were to take the derivative of negative sine x, then we can just take out this constant and we get negative cosine x. And then if we were to differentiate that, we would get sine x. So it's basically just an endless circle from sine x to cosine x to negative sine x to negative cosine x and back to sine x. But that's a bit less important. What's important is the basic derivative for sine x and cosine x. And you will use this in a lot of other calculus functions. So the derivative of sine x is cosine x, and the derivative of cosine x is equal to negative sine x. And what happens if you get something like sine of 2x? Well, to do that, that comes in a later lesson where we look at either the product rule or the chain rule. But until then, keep practicing your math, and good luck with everything. And once again, please drop any feedback in the comment section if you have any, because I also want to improve my tutoring ability and help all of you guys. Thank you for watching and stay tuned for the next video.